first thing I need to do is to say the things I've been saying before again, because I really am concerned that some people haven't quite understood. The first thing we have to do is remember that we have a maximum of 24,000 characters. And those characters include spaces. So every time you hit the space bar, it counts. Then we need to divide our the sequence of what we write up in those things. And obviously, we need the introduction, which we have also called the group problem formulation. And the group problem formulation is probably about, and I cannot be definitive, I cannot be strict, but it's probably somewhere around 1900, around 1900 characters. But of course, then you have your individual. You have your individual problem formulations, and each one is probably around, I don't know, it's about half a page, so it's probably around 700 or 800, something like that, 700 to 800 characters. Now, of course, I cannot dictate what you how much you write, but I can say that there is a maximum, and I can also say that you need to divide your assignment appropriately. So those are the two main features. We've got the introduction, which is the group problem formulation, and we've got the individual problem formulations, which are quite short, but they are that's kind of the PowerPoints that the little PowerPoints you made, but in text. So you write those up, and it will be about 10 lines, something like that, per person. Each contribution, each written contribution needs to be named, because in theory, we need to give individual grades. Although typically we give group grades in third semester, if there is one person who's done lots and lots of work, much more than everybody else, or if there's one person who has done much less work than everybody else, then we need to be able to make a difference in the grades. So you need to write your name next to the work that you write. If you all write something, so if you all write, for example, you might all write the introduction, then you just put in brackets all, like that. So it doesn't need to be done on a line by line basis. It's more like who wrote which paragraph. Okay. So we've got the introduction done. Some people have finished it, I believe. Other people maybe not so much. No. Time is usually short, and there's a lot to do. But assuming that we have finished, assuming that we have, yeah, it's Guantanamo for you, mate.
Why
Because I had 3 lessons in the third semester in Vietnam.
So there was ski?
Yeah.
Okay. You're not the only one?
I don't know if the other one's free.
What number is it?
Hang on a minute. So where were we? Yeah, we're at the next stage. We've got the introduction done. So the next thing you need to remember is that you have to have an appendix. The appendix is your mind map. Or mind maps maybe, but that goes at the back of your piece of work. Then we have the literature search, and we've talked about the literature search, and you need to describe it. You describe the literature search by saying that, first of all, there are different methods. So it's like you answer the question, which ones did we use and why? And then you would talk a little bit about the different results that you got. The different results, the different methods, gathered, something like that. Okay, so we need to know about your literature search and how it worked out. And one of the things, of course, that you then did, we need to know about your coding process. And there you're answering the questions, how did we sort literature? So when you've got the coding process, sorry, I made a typing error there. When you've got the coding process, you write about how you sorted things into different categories. And in a way, when you've done that, you could, if you have space, and that's very important, so if you have space, you could mention a summary, very brief summary. A very brief summary of the sorts of conclusions that you read about. Because once you've sorted all of your work out into different categories, then of course there will be some people that you have read who agree on one thing, and some people who do not agree on another thing, and therefore you're able to summarize in general. Very brief summary, I think, of the coding results. So if we now read down the chat, we can see so far exactly what we have to do up to the point we are at. And
teacher?
Yeah?
Where do we put our methods and coding process? Is in the middle of our essay, or
Yes,
at
it
the
is.
end, or
No, it's in the order that I have described here in the chat, because we, as I told you about, I don't know, 10 days ago, 2 weeks ago, we are not going to answer the questions in the introduction. Okay, the third semester project, the third semester writing is about the process that you would go through, if you were going to do some research. In the fourth semester, next semester, you actually do the research. Okay, so what we're saying here is that this piece of work shows that you know what to do and why you have to do it. right? And so although you might end up writing a little bit about theory, for example, which you will, then you're not actually going to apply that theory. You see what I mean? So you kind of tell me what you would do. So you say, well, we'd start off with a problem formulation, then we'd do a literature search, then we would look at the idea of theory. We haven't done that yet, but okay. And we would see what sorts of results different theoretical approaches would bring us to. So in the third semester, this is very, what should we say? It's very simple because you're not doing the actual research. Is that an answer to your question?
So to my understanding, so it goes like introduction, and then we write about the methods and the coding process, and
Yeah.
the appendix at the end. Is
Yeah,
that correct?
that's correct so far. I haven't got everything. We haven't talked about everything that goes into the assignment, but so far, you are correct.
Yeah. So far as that, right? So we
Yeah.
have an introduction, and then we write about the methods and the coding process, and have the appendix at the end.
Right. And then the
Yeah.
next,
Yeah. Okay.
okay, so then the next thing we need to do is we need to have a theory section. So I'm going to put that in block capitals as well, because we haven't talked about it yet. So we have a theory section, and that is where you talk about different research methods to empirical data. Okay, so the theory section we haven't talked about yet. So this is where I think now that everybody should have their introduction, everybody should have their individual introduction, everybody should have done their literature search, everybody should have coded the literature search and written about it. And now we're kind of moving on to the next stage, the next level. Okay, so I'm going to talk a little bit about writing today, and I will try and talk a little bit about theory today if I have time. And then obviously after the theory section, there would be some sort of conclusion, but the conclusion it's more like reflections on the process. So instead of writing a conclusion where you conclude, you sort of say, okay, we've done 2 plus 2 plus 2, and now we're coming to our conclusion, which is that these 3 numbers equal 6, sort of thing. Now the conclusion is that you look back on your process and you reflect on that. So the conclusion is quite short, maybe, I don't know, 600 characters, maybe a little bit more, maybe 800, but the conclusion is quite short because you will basically end up saying, we found it interesting because, and then you tell me which things you found interesting. So today I want to screen share about the writing and just give you some writing tips, because before you start getting deep into the writing, you need to know kind of what you're looking for when it comes to making mistakes, or should I say, reviewing your writing. So while it's easy for you to sit at the keyboard and write, it is more difficult to be analytic about your own writing, to be objective about your own writing, and see where your own writing can be improved. I mean, I have the same problem. Everybody does. I make typing errors. Yes, I do. I have good ideas while I'm typing, and I think, oh, that's a good idea. I'll put my good idea in here. But maybe actually my good idea doesn't belong where I just put it. And yet my problem is seeing that this good idea is in the wrong place. You see what I mean? You know, because I wrote it, I think it's good. And I wouldn't have written it if I didn't think it was good. So then sort of discovering your own errors becomes quite difficult. You think to yourself, hang on a minute, you know, this was good stuff. I wrote something good here. And it's difficult to get past that feeling that you wrote something good. So I think that the important thing is that you're able, as a group, to look at each other's writing, and that you have some sort of, what should we call them, rules, guidelines for saying to a group member, this paragraph, this sentence needs to be changed. So if you have some sort of standard to follow, like almost like building regulations, if you have some sort of standard to follow, it's a lot easier to say, oh, I think you should change this because, rather than just saying, I think you should change this because I don't really like it. That's no help to anybody. But if you can say why it should be changed, then of course it is a big help. So we're going to talk about writing today. And if I can get my screen share to work, we will look at my screen, I hope, because it's always so slow to react. See, why can it not find what I've got open? I can't move it either. Just trying. I don't think there's something funny going on. I don't know what's going on. Come on. I can't click on the share button. I don't know why not. Oh, this is going to be really irritating. Ah, there we go. Now, got it. Okay, so we're going to be talking about writing. I'm going to take you through what I think of as the... Oh, could somebody just speak and tell me that they can see my screen?
Yeah, we
Yes,
can
I can
see
see
it.
Okay, lovely, thank you. So, I don't know why they're in there. So, we've just been talking about the introduction, right? And the introduction looks like this. And we've talked about this. The first thing you did was frame the problem in general. Kind of, why is anybody interested in BIM? Why would you be interested in sustainability? That sort of thing. Then you focus on your purpose, which is the problem formulation idea. Then you write a roadmap. Now, when I've written roadmap, the roadmap is now your individual problem formulations. Okay, so we start with the big issue, like we did. And then as you're writing your introduction, you say, but there are 4 interesting aspects to this question. and then you would just make very short sentences. So it said, first, recycling is interesting. Second, the reuse of materials is also an interesting topic, and so on. So the roadmap is a very, very brief summary of your individual problem formulations. It's so brief that maybe each individual problem formulation just gets a sentence. And that's why underneath it says number and mention the issues. So you say first, and you write F-I-R-S-T. You say first, blah, 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 blah. Second, blah, 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 blah. Third, blah, 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 like that. Okay, so that the reader knows there are 4 issues. Then you put in your big question, the one which is your problem formulation question. And then you can see at the bottom of the triangle it says the link. And that means that you write one short sentence which tells me, the reader, what I have just read and what I will read in the next paragraph. So you write something like, having described the problem in general, we now move on to describe how we addressed the problem in a literature search. So when you do this, linking, you tell the reader what's going to happen next. That's basically it. It's not complicated. It's just a sentence. And you tell the reader what to expect in the next paragraph, or maybe in the next section. For you, it's the next paragraph in a short piece of work like yours. But the point is that that link helps to keep your logic on the surface of your writing, so that I, the reader, know what's going on. I mean, as your teacher, I know that you know what's going on. And as your teacher, I know that you should put in a link sentence. But as a reader, just like somebody coming in from outside, imagine you gave your work to your uncle or something, he might not be able to follow your thinking because he wouldn't know what was supposed to come next. So when you do your writing, you try to keep your logic on the surface, and that the linking sentence is the easy way. And doing things like numbering, instead of giving people a list and they're not expecting a list, you say first. And as soon as I say first, you are expecting there will be second. You see what I mean? So as soon as you put that word in, you help the reader. So that's what these things are for. Okay, so your introduction looks roughly like that. It does not have to be perfectly like that. So the introduction comes in, and we think to ourselves, okay, most people should be finished with that by now. And you have not yet started your conclusion. Well, of course you haven't, because you haven't concluded. But what we have to remember is that the conclusion is kind of the mirror of the introduction. Except in the introduction, you say, we have this question. In the conclusion, you should be saying, now we have this answer. Question is the mirror of the answer, rather, is the mirror of the question. So I'm afraid I had to write it in very brief notes, so I'll try and take you through it. So the thing is, my purpose. Okay, what was my purpose? My purpose was in number 2, in the blue triangle, and it says focus on your aspect of the issue, the purpose. All right. at the beginning of the conclusion, you tell me, to what extent have you achieved what you set out to do? You had a purpose. To what extent have you achieved it? Well, of course, in your case, you will achieve it, but only in part, because you will have done the literature search and you will have shown me that you know about theory and data, but because you didn't have any data, you're not able to come to a proper conclusion. That's why at the beginning, I said your conclusion will be kind of a summary of your process, because you haven't done any analysis, so you can't really come to a proper conclusion. Then in section 3, your roadmap. So section 3 in the blue triangle, your roadmap. Yeah, what does that mean? It means that in your own sort of research areas, your own problem formulations, you might make some observations, and you can only make observations about your own personal process. Did you find all sorts of interesting literature which was about which would have helped you answer your question, your individual question? And then in the absolute last block here, it says 1 + 4. So there, normally you would generalize a specific from your specific answer. So this is where in this assignment you write your reflections. So although you can't write the conclusion yet, you can now see why the introduction has the shape and the elements that it has. And that is because we have to return to that shape and those elements in the conclusion. So, pardon me. Pardon me. In the paragraph, right? If you, this is the first thing, if you're writing anything down, write this down. Paragraph, 8 to 12 lines of word. If you write more than about 12, 14 lines in your paragraph, the chances are that it is not a paragraph anymore. A paragraph contains one main idea, just one. So as soon as you change that main idea, you need to make a new paragraph. And it's as easy as that. So you have one idea, one paragraph. However, within the paragraph, there are maybe 8, maybe 10 sentences, and these sentences are not just sentences. These sentences have a function. And normally, pardon me again, normally the first sentence has the function of making a claim. So let's take an easy example. I think it's a lovely day. All right, that's my claim. If I were writing in an academic way, I might write, it's a delightful day. It's still a claim because it's still not supported. Okay, so when you take that, you look at the first sentence in your paragraph, you should be able to think to yourself, this is my good idea, my one idea for this paragraph, but that's all it is. It's no more than one idea and one sentence, and I need to make it into a paragraph. So how do I do that? Well, there are two things you can do. You can either make it into a problem, or you can give an example. So I think it's a delightful day today. The sun is shining and the birds are singing. There's my example. And then you could go on to have a solution. It's always a nice day when the birds are singing and the sky is blue. And then you might write something like, having established that it's a delightful day, I will now go on to describe the weather forecast for tomorrow. Okay, so oh, yeah, excuse me, I'm starting to wish I had a drink with me. So you can start with a claim and then go to an example. If it's something to do with sustainability, maybe you make the claim that wood is a sustainable material. Then you might give an example and say, there's this thing called FSC wood. And then you would explain how FSC wood was a solution. That the FSC wood comes from forests where for every tree that is felled, a new tree is planted. You might go the other way, and you might start with a claim and say there's a problem. So you might have you might say, the building industry is slowly turning to sustainable thinking. But the problem is implementing this thinking. And then maybe you have an example of a sustainable project which didn't work because the materials were not of good enough quality, for example. And then the consequence was that the building fell down. You must excuse me coughing so much. So the paragraph can be varied. It doesn't have to be the same structure each time. It's not a bad thing if it is. Sometimes it's a very good thing if it is, because if the paragraph structure is the same each time, the reader knows what's coming next, and you write for a reader. You have to remember, you don't write for yourself, or you don't write for your group so much, but you write for a reader. So if it's the same paragraph structure again and again, then you're practicing that one structure. That's good in third semester, and it's good for your reader. So you could think of it this way as well. You can think of the paragraph as starting with a topic sentence. That might be your claim. It doesn't have to be. And then if you start with a topic sentence and you say something like, sustainability is a great challenge in the building industry. There's my topic sentence. Sustainability is a great challenge in the building industry. But what is sustainability? Okay, so that means now that I have to define my technical terms. So I have to say what I think sustainability is for me, the writer. And then I give examples, and then I explain the example to make my point. So don't just give examples and think that your reader will agree with you. Your reader does not necessarily agree with you. They might even disagree with you. And as we said last time, this exercise we are doing is an exercise in persuasion. So when you give an example, explain it so that it works for you, so that it persuades your reader. So when you've shown me the example and you've explained it, then you tell me what the implications are. What does this excellent material mean? What does it for sustainability in the future? That is the implications. And then you write your link sentence. So maybe in this case, you link from one material to another material. Maybe we link from FSC wood to use the use of bamboo in floors as a sustainable material. So the thing to do is to look at your sentences and make sure that they follow a pattern, that the sentences have a function. They're not just kind of words. So here we have it again. We've got the topic sentence. We've got the defining of our technical terms, give examples, make your point, implications, link to next paragraph. And here we have the introduction. So now we can see that the introduction is a different structure from the discussion, from the rest of what you write. And we can also see, for the same reason, that the conclusion is a different structure from the discussion paragraph. So we have two paragraph structures that are basically the same, introduction and conclusion. And then in the middle, the discussion paragraphs will often follow the structure that I've shown you here. But of course, as we already know, there are two potential structures. And we can, looking at this, use all of these three structures in our work. So if you look at the middle of the screen, you can see that there I'm suggesting what I mentioned earlier, which is repeating the same paragraph structure again and again and again and again. Now in the third semester, particularly, when you're working in a group, it is easiest to repeat the same structure again and again and again and again, because that makes your work look very uniform, very organized, and that is a good thing. But you might choose to be more adventurous, and that is also a good thing, by having different paragraph structures. And then you can see those on the left and the right of the screen. But we still have to remember that the introduction and the conclusion are not the same as the others. So you might use the last one on the left-hand side of the screen when you're thinking in terms of problem solving. So that is all I have to say about that for the moment. Let's just escape and go back. So did everybody understand? Could you send me smileys if you have understood the technical side of the writing? Hello?
May I have a question?
Yes, please.
So the structure that you just introduced to us, we will use that maybe in the middle of our paper, right?
Yeah.
When we're talking about the problems and our method and
Yes,
things like that.
that's correct. Yes.
Yeah, okay. But the introduction and the conclusion will have a different
They
structure.
have a different structure. Yeah.
Yeah, okay. I get it.
Good. Good.
Yeah.
I'd still like to see a few smileys though, please, because it's nice that one person understands, but I'd like to feel that more people understood. Here's the group PF and the individual PF together in the same paragraph. Oh God, they're separate. Okay. Well, I'm going to write separate. If I can hit the keys. So your group problem formulation will probably be a maximum of 3 paragraphs. So let's just put group equals max 3 paragraphs. Individual max 1. So the individual one, I would guess, will be a paragraph of about 12 to 15 lines. So I'm going to write my guess. So for the individual paragraph, the individual problem formulation, it's something like 12 or 15 lines in a Word document. Remember last time we said that 3,300 characters is a guideline. And that's for group and individual. So it's very, I keep saying it, but it's true, because it changes from group to group. But it's very difficult for me to be what is called in English categorical. It's very difficult for me to be definite. I cannot give you a 100% good answer to your questions. And that's why we're talking about it, but it's also when you're writing, maybe you write 4,000 characters. And that's okay, but you just have to remember, now we've written 4,000 characters, we've only got 20,000 more left. So in a way, it's a question of doing your planning and management. It's a way of doing your mathematics, if you like. If you've written 4,000 characters, you've only got 20,000 left. So that must mean that if you as a group make a decision that you want to have an introduction, which is, shall we say, 5,000 characters long, you have to remember that you only have 19,000 left for everything else. You see what I mean? You just have to do your maths. So my numbers are only guidelines. The actual number is a group decision. Please send smileys if you understood that. I don't want that to be misunderstood.
May I ask another question?
Please do.
Okay, so in the middle of the paper where we write about the methods and the coding, our coding process,
Yeah.
Does that part individual or group, or will we need to have both?
When you write, I'll try and put it in the chat as I talk. So when you've got the coding and things like it, right, the processes as you go through the coding, the theory of things, stuff like this, right? That is what you write together. So you don't, but, and this is the thing, But as you're writing together, you have to remember to show who wrote what. So we have one piece of work, and it's let's say it was me, right? And I'm doing my writing, and I say to the group, I am going to write a paragraph about our coding process. Then when I write my paragraph, at the beginning of my paragraph, I would do something like this. And then I would have a heading like that. So I would so that the person marking knows that Bill wrote the paragraph about coding process. And then maybe the next paragraph or the next section is called something like yeah, so we do something like this, and we say, okay, do you get the idea? Hello?
So if I'm not mistaken, the content of the coding process is group content, that the person writing that will be writing their name in front of that paragraph.
Yes, so
I'm not
it's
so
like,
sure.
so it's group work, but one person claims responsibility for doing the writing. Or you might even, and this is possible, you might even do this where you, hang on a minute, you might even have, oh dear, just a moment. You might be two people who wrote the same paragraph or two paragraphs. It might be two people who did it together. That also is okay. And that's why it's okay when you write the first problem formulation that you write all in front of it, so that I know that that everybody wrote this. And this is a help for you, because it helps you see who's good at writing and who can maybe improve. It's a help for me when I'm asking questions in the exam, because then I know who wrote the piece of work, and then I can choose, and I can say, Kang wrote this piece of work, but I'm going to ask Anne the question, because it's group work. So Anne should know the answer to the question, but if she doesn't, then Kang, who did the writing, can help her with the answer. Do you see what I mean?
So basically, the content that we're writing is a group work, but the person that writing that will have their name like in front of the heading, right?
Yes.
Yeah. Okay. Got that.
Right. And that and as I say, in the exam, which is also a consideration, I can either ask the person who wrote the paragraph a question about the paragraph, right? Because I know Kang wrote it, so I can ask Kang a question. But because it's group work, I can ask anybody in the group about the thing that Kang wrote about, and if they can't answer, it's a bit of a shame. You know, it's not a bad thing. It's just a bit of a shame. But the good news is that Kang, who did the writing, can step in and say, "Oh, I can answer that question." Do you see what I mean? So I can either use these names in the exam to check that the writer knows what they wrote about, or I can use these names to check that the group knows what was written about. Do you see what, do you see? It kind of works two ways, but it's in the end, it's kind of the same thing. So,
Yeah, I
yeah.
think about that.
So, I don't know what I've done here. Hang on a minute. Yeah. I'm just going to start another one. That sort of takes us to the end of the. Why can't I open this? Come on. I can't. Something's locked. Oh, there it is. So that takes us to the end of the what I had to say about the writing for today, because I think that it's important that you have a look at the writing. And if you look now at Canvas, you can see that there are loads and loads of resources out there to help you for your group work. And so what I'm hoping that you will do now is to take the document that is called Cohesion and Coherence, and it's a PowerPoint. So it's called 3_ELT writing 3 coherence _cohesion, no voice. I want you to take a look at that while just for 10 minutes, because as you heard me coughing, I am desperate to go and get a drink. So if you can take a look at that for 10 minutes and try and understand it, and if you have any work that you're writing on, you might take some of the words from that PowerPoint and start to introduce maybe one or two of them into your writing. Okay, but I've just got to leave you for 10 minutes to go and get a drink. I hope that's okay. Send a smiley if you have understood. I will be gone for 10 minutes. Okay, thank you very much. You have some work to do. I will leave you to do it so that I don't die of coughing. So you've had 10 minutes to have a quick look at the module and specifically have a look at the ideas of cohesion and coherence. Now, those documents are up there to help you. They're not teaching documents, they're there to help you. So they're there for time when I give you time. So for example, maybe at the end of today, I'll give you half an hour to look through them. Anyway, I'm going to have a look at this long question to start with. What we thought, big issue, yes. Then we separate into individuals, up to the number of type all this down to make sure that this is so thank you. Okay. Thank you, Tran, for your very long question. I'll try and take it piece by piece. So we are saying there is an introduction, and that's the big issue, and that is also the group problem formulation, and it's around about approximately 3,300 characters. Then you can add to that 700 characters per person. For the individual problem formulation, and I think maybe that's about 12 to 15 lines. When we do our maths, we find that we have 3,300 plus, let's say, 2,800. So we're already up at about 6,000 approximately, which means that we have 1,900 characters left for everything else. Then there is the process description, you're quite right, and it will be started with a theory section, then the methods for doing the literature search, actually the reverse order, it will be literature search first, then the methods and coding. But, okay. Okay, and conclusion of bibliography and right. Okay, so there is just one thing here. And let me see, yeah. There's just one thing I want to say, and that is not correct. So it should be, it should look like that. So we will have a theory section, which we have not yet talked about, but we will have a theory section. And that will have something about methods in it, and there will be a literature search and the coding of the literature search. So the one thing that I've mentioned today that you missed, Tran, was the idea of a theory section. So we are going to have a theory section, and in fact that's what we're going to talk about now. So that's why you didn't put it in. It's because you didn't know, but we are going to have a theory section. So let's just see if I can do the screen sharing thing again without any problems. Could somebody just confirm that they can see what I can see, which is my PowerPoint?
Yeah.
Okay.
Well, we can see the PowerPoint.
Lovely, that's good. So in our piece of work, we have to have a section which is called theory. Now this is confusing in third semester. In fourth semester, it makes perfect sense. In fifth semester, it makes perfect sense. But in third semester, it is confusing. So I'm going to speak slowly, and I'm going to repeat myself a lot. Okay. First of all, we have this definition of theory and what it does. It explains and predicts. Those are the two most important words when it comes to answering the question, what is a theory? So we're not interested in theories that are conspiracy theories. We're not interested in theories that people make up when they're having a conversation and they say, oh, yesterday was a nice day in theory. Yeah, what theory? Nobody knows. In the scientific world, theory is a very special thing, and the theory is something which explains and predicts. And this is why, for example, Einstein's theories have become more important as time has gone on. So since Einstein came up with his theories, these theories have not only explained, that's what they did to start with, but they have continued to explain, and people have used them, scientists have used them to predict how light behaves when it comes to a black hole and things like that. And sure enough, the theory still holds true. So a theory is a very big concept. It's a massive, complicated idea which can be explored, but basically it explains and it predicts, and it continues to do that. So if we take as an example the theory of evolution, Darwin's theory of evolution, some people say, well, it doesn't work. And some people say, yes, it does. But the overwhelming proof is that it explains how, for example, scales became feathers, and feathers are now what is on birds as we know them, but in fact that birds are in the reptile family. So they're in the same family as snakes and lizards. So the theory explains and predicts. It's very important that we know that. So we can't just use the word theory in a casual way, because it's such an important word. So in theory, what is theory? Well, when people are just talking, ordinary people like me, like you, like your neighbor, ordinary people are talking. It is a vague and fuzzy sort of fact that nobody really questions and nobody really understands. It's more like a gut feeling. It's uncertain and it's unproven. So, for example, conspiracy theories. Here we are, man with tinfoil hat. If you have a theory which is not fully formed, then of course it explains things, but it does not explain them in any complete way. If you have a scientific theory, on the other hand, it is an explanation of natural phenomena built up logically from numerous testable observations and well-tested hypotheses. I'll go back and explain that in a minute. And it is well established, broadly accepted, complex ideas that explain. So this is like the Einstein theory example that I just gave, where Einstein came up with various theories. He did that a long, long time ago, but his theories are still good. And they're good because they are broadly accepted. They are complex ideas which can be explored by other scientists and which explain certain phenomena. So there you go. Einstein's theories are an excellent example of what the word theory means when we are talking about science. Let's go back to the bit that says scientific usage, the heading in the middle. I'd like you to focus on that. It says there's an explanation of a natural phenomenon. Okay. Now, natural phenomenon. First of all, these are things which happen. Okay. It's, in a way, it's very simple. So anything that happens around you is a natural phenomenon. Let's take some simple but easy examples. Here's an example.
Teacher,
Yes?
are you changing the slide? Because
No? I'm still on the slide which is called What is Theory?
okay.
Okay.
Yeah.
So I'm looking at the scientific usage section in the slide that is called What is Theory? And it's this idea of natural phenomenon. Now, if you think about shopping, shopping is a natural phenomenon. That's something that people do. They don't think about it. They don't plan it in some sort of strategic way. But there are certain things that are part of shopping. For example, if you're going grocery shopping, maybe you make a list. But one thing that you will nearly always do when you are shopping, which you do not plan to do, but you know you have to do, is stand in a queue. And we know that this is a natural phenomenon because there is not a sign in the supermarket which says, please stand in a queue. Everybody knows that they have to get in a line and that they wait their turn. And we know that they have to wait their turn because if they don't, then somebody will notice and they will turn around and they'll say, hey, you can't go first. There's a line. There's a way in which these things happen. And the way in which I pay for my things when I go shopping is to stand in a line. I can't just go straight there and be number one straight away. I have to wait, and I have to wait my turn. Now, this is a natural phenomenon. You may not think of it that way, but it is, because that's how it happens. And it happens that way more or less everywhere in the world. So this must mean that it is nearly always true that shopping, there is this natural phenomenon that you have to stand in a line. And we could do lots and lots of observations of different queues, different lines, in different shops at different times, and we could test the hypothesis that people stand and wait their turn in lines when they go shopping. And we can test it by having one person go to the front of the queue, go to the front of the line. So even something like shopping is a natural phenomenon. But of course, when people think about formal science, in the what should we say, in the chemical sense, when you do experiments at school, as I'm sure you did, be something. There would be this substance, let's call it water, H2O, and then another substance called sulfur. And I can't remember what that is actually, but anyway. And if you put sulfur in water, there is quite a, what should we say, powerful reaction. And the sulfur kind of fizzes round and smokes a bit. Now, that is a natural phenomenon as well. And we can test it again and again by taking buckets of water and putting some sulfur in, and the same reaction will take place every time. So then we can have a hypothesis that sulfur and water do not mix. In a chemical sense, they do not mix. And we can test that then. And we can say to somebody who does not know this, put these two substances together, because we have a hypothesis that they mix, because there is the chance that maybe one day they do, but no, they don't, and they fizz round and they smoke and they bubble, and so we can test it again and again and again. So this is what a theory does. The theory explains and it predicts. So I can develop a theory about sulfur and water and why they won't mix, because I can analyze their results and I can analyze the components and I can see what it is that does not match, if you like, that stops them mixing. So there is a theory, there is a thing which is like a theory. And here we can see in the background that there is a flat planet Earth. And once upon a time, everybody believed that the Earth.
Teacher?
Yeah.
Yeah, are you on slide 3?
I'm on what is theory not?
Yeah, we cannot see the slide changing.
Really?
Yeah.
Oh, that's weird. Okay. I don't know what to do about that. Let me just, because this is quite
Yeah.
important.
I think there's a problem with sharing. Maybe you share the PowerPoint like user interface, but not like the slideshow.
Well, according to my computer, I have done, because I can. I have a little button which says stop sharing. But anyway, never mind. I'm going to stop sharing. I'm going to escape, and I'll go. Instead of sharing, if you could find yourselves on. Oh no, you can't find. I haven't loaded this one up. I'm not sure what to do now. Hang on a minute. I'm just going to turn my microphone off. I'm going to have to talk to myself a bit and talk for 2 minutes. Just a second. Okay, I think I've fixed it. So I've now put the PowerPoint I was talking about into Canvas, so you can follow it from there. And it's in the theory module, and its name is that. So if you refresh your Canvas module, Canvas, and then you go into the theory module, you should be able to see it. Can we confirm that you can see it this time?
Yes, we can see that.
Okay, then I think what we'll do, instead of me screen sharing, I will just tell you which slide I'm on, and I will start again. Because if you couldn't see what I was talking about, it makes it harder to understand. So I will tell you that now I am on slide 2. What is theory? Okay, and because you've heard it before, I will be a little bit quicker than last time. But the first thing to notice is that there is a popular way of using the word theory, and this is not the same as the scientific way of using the word theory. So we are trying to be scientists, so we have to use it in a scientific way. And we have to think of explaining natural phenomena. So the thing is, you have to write this theory section, but you're not actually going to write about a theory. And that is why I said right at the beginning, it will be confusing, because although we are calling it a theory section, you're not actually going to write about theory. Okay, now that is confusing. So what I'm going to try to tell you is what you are going to write about. But first of all, we need to know what a theory is. Okay, so that's where I'm going first. Then I will tell you what to write about. So in your work, you need to be able to supply a definition of theory. So you need to be able to answer the question. You have a theory section, and you answer this question: what is scientific theory? And as we go, I will try to give you some help, which will tell you what the answer to this question is, so that you know what to write about. Okay, but basically you've got a theory section, and it's called What is Scientific Theory? And that, what is scientific theory? That is probably one paragraph. It is not a lot. So you can only be very, very superficial. You can only scratch the surface. You can give the reader a definition, perhaps a quotation. You can explain it, and then you kind of move on to the next paragraph. All right. So this is very, very quick. Because the work that we do about theory, that mainly comes in 4th and 5th semester. Right now, you just need to show that you know what a scientific theory is. So, looking back at the PowerPoint, you need to mention that it is testable, and that it is based on hypotheses, and it explains naturally occurring phenomena. So when it comes to what is a theory, we know that it explains It predicts. Maybe you give me examples. So the key words to include would be explains, predicts, natural phenomena, and that it's explains, predicts natural phenomena. And the other thing that you need to mention is that it is testable and repeatable. In other words, if you do a test, let's say the queuing example. So we have lots and lots of video recordings of this natural phenomena of people standing in lines. And then we have lots of examples of people going to the front of the line. And people in the line saying, hey, you can't do that. Then we know that there is a kind of a natural rule that when you see people standing in a line, you have to observe the rules of the line. And one of the rules of the line is you go to the back, and when you get to the front, it's your turn to pay for your shopping. That's just one of the rules of the line. And there are other rules of the line. In these days of COVID, for example, there might be some other rules of the line, like you must stand 2 meters apart. And if people get too close, somebody might say, hey, back off. Or they might say, take a pace back. But they say something that in some way shows that they know what the rule is. And you could test that rule by getting people to break the rule. And then you would see that people reacted to the rule. They talked about the rule. So when it comes to theory, keywords, explains, predicts, natural phenomena, it's testable and repeatable. So what is theory not? Okay, this is the thing. Once upon a time, there were people who believed that the earth was flat. They did this because the theory explained that it was kind of explained what they could see. So if I was standing on the coast, I'm standing on the beach, and I look out to sea, basically, the earth looks flat. And there is a slight curve. If I can see enough of the sea, I might be able to see that what I can see out there in the ocean is a slight curve. But they believed that the earth was flat because no matter how far they sailed towards the horizon, the next horizon looked the same. It was flat. So, of course, the earth was flat. Even when you could sail all the way around the earth, it still looked flat when you were standing on the boat. But of course, that was more of a belief than it was, if you like, testable. It wasn't really testable. Is the earth flat? Well, no, because if you test whether something is flat, let's imagine you have a table and you say, the table is flat. There comes a time when things will fall off the table. But when it comes to the earth, nobody falls off. Didn't matter how far you sailed, you didn't fall off the edge of the horizon. So that meant that people had to sort of review their idea of whether the Earth was flat or not. So the idea that the Earth was flat was more of a belief than a theory. So moving on to the next slide, there are levels of scientific knowledge and there are laws. Now, if something is a law, it is always true until it is broken. And if something is a law and it is broken, then there will be a consequence. But if something is like the theory of evolution, it is the one that does the explaining. You see, so it explains in a very complicated way. It explains and classifies how, for example, human beings are related to chimpanzees, and then it is able to show the development. And if we think back not very far, maybe, I don't know, 50 years or so, 50 years ago, DNA was not really understood. I think it had been discovered, but it wasn't really understood. Now, DNA is analysis is so far advanced that that's what the COVID vaccines are based on. It's based on DNA analysis. So there we have this theory that you know, everybody shares the same sort of DNA, and you know, therefore, for example, we can look at the kidneys of pigs and the eyes of pigs, and these can be used for transplants into human beings because they share, we share enough DNA for that to work. So we've gone from not really understanding DNA to being able to explain why certain things work. So this is the thing about the theory. It explains, classifies, it shows development of some sort. And it might be development in a species, for example, or not. It might be development within a species or across. A hypothesis is a really important word. I know this word, I'm going to explain it, but a hypothesis is an idea about how things work. So if you have a hypothesis, you try to build your idea of how things work within your theory. Remember, the theory explains and predicts. So if I can predict something, then I will have an idea of something which can be predicted. So let's take the standing in line example again. If I have the idea that standing in line is a social rule, and I have a theory that will explain that behavior, then I can predict, and I can predict people will stand in line in shops. But I can also predict if you don't stand in line in shops, somebody will say something if you go to the front of the line. Now, that might be my hypothesis, but then I have to test it. So maybe I have lots and lots of cameras and they show lots and lots of people standing in line, but maybe nobody says anything when somebody goes to the front. Then, of course, my hypothesis, my idea, if you like, that people will say something, doesn't work. So the hypothesis is the scientist's idea based on the theory. Okay, it's very important you know that. The scientist's idea based on the theory. And one way to test it is using empirical data. And empirical data is information, data, from the empiry. And the empiry is like the real world. So this is where, of course, I would make lots of video recordings of people standing in line, because I would need evidence from the real world. So this idea of hypothesis and empirical data, these ideas need to go into your assignment, and you need to explain them. If we look at the difference between a hypothesis and a theory, a hypothesis is an idea to be explored by gathering empirical data, right? The analytic attitude rests heavily on a theory, top down. Should the analyst work with a subjective supposition? The analytic methodology rests heavily on coding data to uncover patterns bottom up. Okay, let's look carefully now at this left-hand side of the slide, because it's rather dense. The hypothesis is the idea that we have, because we have a theory which explains and predicts. So I look at my theory, I say, this explains and predicts people's behavior. Now I have a hypothesis, and I know that my theory will predict, and therefore I think that my hypothesis is probably true. Probably. I don't have any proof, but it's probably true, I think. And I think it because my theory says that it's okay to think that. But this, to look at the next bit, this attitude is very top down. Now that is to say, it is the analyst who decides on the hypothesis, right? Now that could be a bad thing, and it could be a bad thing because I am a human being, and my idea, my hypothesis, might be wrong. But I might not want to admit that. I might not want to be a professor who is wrong. See what I mean? It's better to be a professor who is right. So the problem with being top down is sometimes that you try to prove your hypothesis because you don't want to be wrong. So if we work our way down here, a subjective supposition. Now, a subjective supposition is an idea that you have, but it doesn't really come from a theory. It's just an idea that you have. You don't really have a theory to support yourself. So if I want to show that my supposition is correct, I have to go and get data. So if I have a supposition that people will shout at me if I go to the front of a shopping line, that's my supposition, then I have to get data. That would be, shall we say, video recordings of people in shopping lines. And if people shouted at me, that would prove my supposition. But if nobody shouted at me, then my supposition would be incorrect. If we look at the other side of the slide now, you can see that it basically works the same, but when you have a hypothesis, it is your idea, and the hypothesis and the analysis are, if you like, in the head of the analyst, and they're not even based on experience in the real world. They might be based on scientific experience, but not real world experience. So this is when you're working top down. It's when you start off with your own good ideas and then try to prove them. So you have these preconceived models. And a preconceived model, that might be something which is triangles and circles and squares all put together. And you say, this is how the world works. It works in these models. Now, models of, shall we say, people's behavior, or how a comet behaves in space, these models might overlook tiny, real details. And we cannot overlook tiny, real details. So generally speaking, when you work with a model of that sort, not a BIM model, but when you work with a model of that sort, it overlooks the details of what really happens and tends to explain what happens in rather more general terms, using the theory to help it. So there are two different ways of looking at things. There's top down and there's bottom up. And bottom up analysis, you have a theory, but on the other hand, you don't. So the analyst has no preconceived ideas. Now this is of course unlikely, because everybody has preconceived ideas. You couldn't get out of bed in the morning if you didn't have preconceived ideas. So everybody has preconceived ideas, but when you work bottom up as an analyst, you try not to use your preconceived ideas. What you try to use instead is data, and that might be statistical data, it might be different sorts of data, but you use data and you try and find the pattern in that data. Then you find the regularities. The regularities allow you to analyze common phenomena. Then you can draw defensible conclusions, because defensible conclusions are based on what really happens, this empirical data. So when you do bottom-up analysis, you try not to have too many ideas in advance. Then you get your data and you try and use your data to find the patterns. And then when you've got some patterns, you can say, my data shows, right? So that is bottom-up analysis. And when here in the triangle, at the bottom, it says unmotivated data collection. Unmotivated is a word which refers to the scientist, okay? So the scientist's analysis is not motivated by the idea that they want to prove. So the scientist is not motivated by a hypothesis. The scientist is motivated by to look at the data and see what the data shows. So this is something you have to explain. And then we have this top-down analysis. This is what we've talked about. In top-down analysis, the scientist starts with preconceived ideas. They start with ideas that come from their theory, the theory which explains and predicts. And because they have an idea beforehand, they then gather data, and that is a good thing. But their problem, because they have an idea beforehand, is trying not to prove the idea that they have beforehand. So they might have a preference for data which supports their ideas. Of course, that would be bad. So the theoretical scientist does his to prove their own ideas. And the empirical data-based bottom-up scientist tries to discount, tries to not have too many ideas, but let the data give the ideas, because the data shows regular patterns. So on the one hand, these things look like the opposite of each other, but on the other hand, they have their similarities. So there is no analyst who is blindly rigorous in their analytic procedure. So this means that the two attitudes, right, the top down and the bottom up, actually share quite a lot in common, because they use the same data. So the difference must be the scientist. Is the scientist someone who wants to prove their own ideas, or is the scientist someone who just pretends that they're not part of society and have no real ideas? Or is there a sort of compromise? And of course the answer is there is a compromise, because scientists have ideas. So your problem in your studies is to explain the role of theory and what to do. So this last slide, the last two slides here, you have to write about what I have just tried to explain. You have to try and explain the difference between top down and bottom up. And you probably need to rely quite heavily on this PowerPoint. And what to do in your piece of work is described in the last slide. So let's just go back to here. This is, I don't know how you're feeling, but I think this is quite hard work to explain. I have the feeling that it's even harder to understand. So in third semester, again. In third semester, I can feel myself getting tired. Here we are. Oh, for God's sake, I can't see it. How tired I'm getting. Right, so in third semester now twice, but in third semester, your job is to have a theory section, but you explain the difference between top-down analysis and bottom-up analysis. You will need some key words to do that. And I think the easiest thing to do, just a second, I need to remember exactly where to go now to find it. There. There it is. There is a module. There is a module called Theory and Method. If you now go to that module called Theory and Method, you will find that there's a questionnaire there. And the questionnaire contains the key words you need to mention. So the PowerPoint I've just showed you is your starting point. You have to try and include the word in the questionnaire. And what I'm going to do now is I'm going to go and take a little break just to get my brain clear. And you are allowed to take a little break too. But what I'd like to do when we come back is to take questions, okay? And your questions might be based on the questionnaire or the PowerPoint. But what I've just tried to explain takes some time for you to think about and talk about, and then you have to write about it. So the process now is a brief break. Then we talk about the questionnaire. Oh God, we talk about the questionnaire. We talk about this questionnaire, and then you really need, as a group, to start thinking about tomorrow and writing some sort of theory section. However, we are going to take a break now, and I will be back with the microphone on in 15 minutes.